Chapter 2, Section 7. This is the last section that's in Chapter 2. So you'll be upcoming on a quiz, 2, 5, 6, and 7. And then after that, we're going to have a Chapter 2 test. All right, inverse functions. We've done this also in Algebra 2 and Honors Algebra 2 as well. All right, definition of the inverse of a function. Let f and g be two functions such that f of g of x equals x for every x in the domain of g, and g of f of x equals x for every x in the domain of f. Okay, they're talking about the inside. Remember when we spoke about the domain of the composite function, it was you had to include all restrictions of the inner function and then the composite as a whole. But when you find f of g of x and then g of f of x, if they both equal x, then the two functions are inverses of one another. The function g is the inverse of the function f and is denoted by this. This is not f to the negative 1 power. You say this is f inverse. Okay? Thus, f inverse of f of x is got to equal x, if in fact they are inverses of one another. The domain of f is equal to the range of f inverse, and vice versa. Folks, when you're talking about inverses, you're talking about the switching of the x's and the y's. Really, that's what it comes down to. When you're asked, and you should have read this in your textbook, when you are asked to show or verify that each function is the inverse of the other, what you have to do is compute or find f of g of x and then g of f of x. So I'm going to set up f of g of x. F is the outer function. That's 7 times parenthesis. What goes inside the parenthesis? The g function. When I multiply these, I get 7x over 7, or the 7s will divide out, and I'm going to get an x. It has to work both ways. It can't just work one way. G of f of x is I take the g function, parenthesis for x over 7, put the f function inside, and again, the same thing's going to happen. The 7s are going to divide out, and you're going to be left with x. Because g is the inverse of f, and vice versa, we can use inverse notation. So we would substitute. If we want to say that this is the inverse of this, we'll say f of x equals 7x and f inverse of x equals x over 7. It would be improper for you to use the inverse function notation if the two, in fact, are not inverses. So be cognizant of that. All right, so make sure that, f of this function and f inverse of this function are both equal to x before you use this inverse function notation. There is like a quick way of checking. I really want to see you doing the algebraic work, but there's an easy way of checking or at least guessing what the inverse could be, because remember, inverse is exactly, what it seems, but everything is with respect to x. So remember that in algebra land, everything is about x. So with respect to x, I'm looking at this. This is 7 being multiplied with x. What would the inverse be? Well, to divide x with 7, right? The inverse of multiplying x with 7 would be to divide x with 7. Okay, so to me it makes sense that these are inverses. Again, I really, on a test or a quiz or even in your homework, especially for the bigger problems, you should be showing this algebraically. All right, side 2. Show or verify that each function is the inverse of the other. All right, f of x is 4x minus 7. G of x is x plus 7 divided by 4. Now, the easy way, or the shortcut way, or I'm going to try to guess if they're inverses, is with respect to x now. What's the inverse of subtracting 7 with x? Well, that would be add. What's the inverse of multiplying 4 with x? Well, that would be dividing x with 4. And this is not a I mean, it's a quantity, but it's not grouped together as a quantity. This is like a product and then subtract 7. What's the inverse of not being grouped together? Well, grouping it together. And so we come up with this. This is a x plus 7. Yep, that's the inverse of that. And then divide by 4, and you're actually grouping this together. It's this quantity x plus 7 divided by 4. So to me, it makes sense that they are inverses. I look here, I'm going to find f of g of x and g of f of x. I'm going to set up my scaffolding and put my g function inside here, put my f function inside here. And when I could do this computation, I do get x. So if f of x is 4x minus 7, I can conclude that the inverse function is x plus 7 over 4. Okay, don't let this be difficult. You know, this is in the numerator. This is 4 over 1. These 4s are going to divide out, and these 7s are going to sum to 0. You are going to be left with x. Okay, moving on. Finding the inverse of a function. This is an algorithm, and it's really not that terribly difficult. Because, again, the inverse is, these are all about switching the x's and the y's. You know, what's the inverse in algebra land of x? Well, that would be the y. And what's the inverse of the y? Well, that would be the x. So you switch the x and the y. So finding the inverse of a function, the equation for the inverse of a function can be found as follows. Replace f of x with y. I want to physically see the y. And then you switch the x and the y. And then you solve for y. And this part here, most students can do. It's the solving for y that gets them sometimes. I'm not quite sure why. If this equation does not define y as a function of x, then the function does not have an inverse function. And you can test that by finding f of g of and g of f of. Or sometimes you can look at the equation and say, that's well, not necessarily a circle, but that's a sideways parabola. That's not going to be a function. And so we can kind of tell just by looking at the equation. Is it linear? Is it quadratic? Is there plus or minus? Okay, that kind of stuff. All right, down yonder. Find the inverse of this. You should have went through this process already in your notes. Replace the f of x with y so I can physically have an x and a y that I can switch. That's what I did here at this step. Now I have to solve this equation for y. I'm going to subtract 7 over to the other side. I get x minus 7 equals 2y. Because I like my y on the left side, I'm going to switch it over. I'm actually dividing both sides here by 2 and then putting my y on the left side. So I get a quantity x minus 7 over 2. This is a function. Folks, it's linear. This is 1/2 x minus 7/2. Because I know this is a function, I can replace the y with inverse function notation. Okay, so again, I busted this apart. This is x over 2 and 7 over 2 with subtraction in between. And x over 2 is the same as 1/2 x. All right, I know this is linear. This is a graph of a line. It's a function. So if you have questions on that, please let me know. All right, the next example. We found the inverse of the function f of x equals 2x plus 7 to be f inverse of x equals x minus 7 over x. 2, rather, I'm sorry. X minus 7 over 2, right? Because you were dividing by 2. We can graph these. And we can make tables, okay? So here in this example, I'm going to zoom out a little bit on my, here we go. All right, so I can start with this and substitute my values of x inside and get my y's, my output, right? So up here, 3 minus 7 is negative 4 divided by 2 is negative 2. 5 minus 7 is negative 2 over 2 is negative 1. 7 minus 7 is 0 divided by 2 is 0. 9 minus 7 is 2. 2 over 2 is 1. Okay? So that's how we found these values, by substituting these into the function. Folks, the inverse is all about switching the x and the y. So all you have to do is take this table and flip it. all the y's become x's on the inverse function, and all the x's become y's on the inverse function. And you could test it. Substitute. Look at it. 2 times negative 2 is negative 4 plus 7 is 3. 2 times negative 1 is negative 2 plus 7 is 5. And so on and so on. So we plot these ordered pairs. And we see that there's actually a reflection on our coordinate plane. And it's across a special line, which we get to later on in the chapter, which you should have read about already because you have these notes done already. All right, so again, for inverse functions, if you're given some values, make a table, and you can get the table of the inverse function, plot those points, and draw your graph. Example 4. Find the inverse of 4x cubed minus 1. So for me, I like to try to guess the inverse. It's all with respect to x, though, right? The 1 here is not grouped with x. So it's the way it's like 4x cubed minus 1. So the inverse of not grouping with x would be to group with x. And not subtract 1, but plus 1. So I'm thinking x plus 1. The inverse of multiplying x with 4 would be to divide. So I'm thinking 4 is in the denominator. And the inverse of cubing is cube rooting. And so I'm thinking, here, inverse of subtraction is addition, inverse of multiplication is division, inverse of cubing is cube rooting, inverse of away from x is inside with x. So when I look at my final, oh, look at that. The cube root of this fraction, quantity, x plus 1 divided by 4. And if you look, I'm replacing the f of x with y. I'm switching the x and the y. I'm bringing the 1 over. I'm then dividing by 4. I am then finally taking the cube root. And it is the cube root of this fraction. Okay, it's very regimented. Don't let this be something that's difficult. You have to remember all your equation solving skills. All right, the next page. Find the inverse of the quadratic function. Oh, here's where you're going to get a sideways parabola. Okay, so the inverse of a quadratic function here, f of x equals 2x squared plus 1. I'm going to make the f of x become a y because I want to physically see the y so I can switch the x and the y. And then I'm going to solve this for x. I'm going to subtract the 1. I'm then going to divide by 2. I have a y squared equals this. And when I take the square root, it's plus or minus. We know this is not a function. And because this is not a function because of the plus or minus, it would be inappropriate to replace this y with f inverse of x. Because it's not a function. It's not. This equation is the inverse of this. But the inverse is not a function, so I can't use function notation. This is really the square root function, the positive and the negative. So you'd be graphing the top of the square root and then the bottom, which ends up giving us a sideways parabola. Okay, and we know that would not pass the vertical line test. So that's not a function. We cannot replace this y with f inverse of x. Horizontal line test. Well, horizontal is the inverse of vertical. And so if I'm given the graph of some function or non-function, okay, I can do the horizontal line test to see if the inverse is a function. A function f has an inverse that is a function f inverse if there is no horizontal line. So we have the vertical line test to tell if a graph is a function, and now we have the horizontal line test to tell if the function has an inverse that's a function. All right, so I'm looking at these graphs right here. I know this is a function, this is a function, this is a function, and this is a function. They're all functions because they all pass the vertical line test. But they're not all functions who have inverses that are functions because they do not all pass the horizontal line test. Okay, this one has an inverse that is a function. Why? It passes that horizontal, or the pencil test, right? It passes that horizontal line test. right? It's not going to fail. It's not going to touch it in more than one place. So if I do the horizontal line test, it's only going to touch it in one and only one place. So this is a function that has an inverse that's a function. This fails. This is a function that has an inverse that's a function. This is a function whose inverse is not a function. Again, this part here, all the functions are functions. Why? Because they all pass vertical line test, and they do not all have inverse functions because they do not all pass the horizontal line test. Okay, they have inverses, but not all the inverses are functions. All right, you got a question on that? Please let me know so I can help you out with that. Finally, this part here, which you should have read in your textbook, the graphs of f and f inverse, you will see reflection on the coordinate plane across the line y equals x, that identity function, or that linear identity function, right? So if I look here, and I believe I gave you these tables with these values in there, you could get the inverse function table by just simply taking the x's and the y's and flipping them. You just switch them, that's it. Switch the x's and the y's. So I graphed the blue table in blue. I graphed the orange table in orange. And if I fold my coordinate plane across that line, y equals x, this dot will lie on top of that one, this one on top of that one, this one on top of that one. There is symmetry about the line y equals x. Hence, these two functions are inverses of one another. They both pass the vertical line test, so they are functions. The blue one passes the horizontal line test, so we know its inverse is also a function. And the last one, same thing. You take the table. I'm going to tell you right now, like on a test or a quiz, it's going to give you a picture of a graph. What you should do is identify some points, make a little table with the coordinates, make a second table, and just flip-flop them. That's all you do. Right? Inverse, inverse, inverse. All the x's become y's, all the y's become x's. Domain and range. The domain of the function becomes the range of the inverse function. The range of the function becomes the domain of the inverse function because you're switching them. And again, if I take this coordinate plane and fold it about that line, y equals x, this point's going to lie on top of that point, this one on top of that point. Okay? So if you have questions on that, please let me know. There's a textbook assignment for you. Make sure you're checking your answers in the back of the book. And ask me some questions for feedback. You have that homework discussion. Please use that. All right. I will see you when I see you. Have a great day.